Our next two sections are all about how to find extrema. But first, we need to think about our different types of extrema because we have two and very different ways to find them. So we have one, which is called an absolute or global extrema. This is for a function defined on a closed interval. If there is some value of c within that closed interval, right? So this is some value x can take. If f of c, the output when we plug in that c, is greater than f of x for all other x's on that interval, that is an absolute maximum. All right, so we need a c on that interval, and if the output for that c is larger than the output for every other thing on that interval, that is an absolute maximum value or a global maximum. And if we have a c such that f of c is smaller than every other output on that interval, then that's our absolute minimum. So if it's the biggest thing or the smallest thing, that's a global or absolute extrema. This is different than a relative or local extrema. A relative or local extrema just says if there's an open interval. So now we're not saying this closed interval. There's going to be a reason for that, but we won't get that until we get into 5.1.3, into the whole definition and how to find these global extrema. But now we're on an open interval on which f of c is a maximum, then f of c is a relative maximum. So if there is some interval, could be anywhere, any interval where it's the largest value, it has to be an open interval, then that is a relative maximum. So, hmm, hmm. Let's think about this really quickly. So in terms of an absolute minimum or maximum, just want to throw this out there. This can happen on a closed interval. It can happen at an endpoint, right? Here's our overall maximum for that value. What happens on the endpoint? The endpoint is within the interval of a to b. It is larger than every other value. It also happens to have a global minimum that's also within all of our closed interval. Now, open interval means that the endpoints are no longer up for grabs. The endpoints do not count. So when we're talking about local extrema, we are now looking only at in a smaller window where I can go to the left and right of some point. This is what we mean by that open interval, some sort of like neighborhood. That's what we call it, a local maximum or local extrema. Within some neighborhood, if I can go ahead and make a little like, it's the largest point, right? Where I can't make a neighborhood around this because wah, 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 I don't have the right side of it. So this is a sort of interesting idea too, that just because something's an absolute extrema doesn't mean it's a local extrema, because local extrema have to have that neighborhood to either side, have to be on an open interval, whereas our global extrema are on a closed interval and can be an endpoint. So huge distinction here. Let's go ahead and try to put some words to this, and then let's look at an example, a picture from a different, I think it's from a different set of the notes too. I don't remember actually. You know, me. Oh, actually, it's from the set. We got it. All right. So a relative minimum or maximum, that's what we're focusing on right now. A relative minimum or maximum is just smaller than or larger than the points around it. That's all it matters, right? I mean, honestly, that's how I would define it. It's smaller than stuff to the left and right, and we need the left and the right. That's the open interval. Now, if you want to think about when that happens based on a drawing, you might start thinking about what we're going to call the first derivative test, right? That local minimum, it happens and it has to happen when my actual function goes from being decreasing to increasing. That's the only way for this to occur, right? To have a local minimum. So we could even write that. When f goes from decreasing to increasing. Maximum, all the other stuff, right? It is larger than the values around, blah, blah, blah. And instead, we're going to go from increasing to decreasing. And again, we could think about that happens increase, And if we change to decrease, well, then that point at the top is probably, not probably, has to be a maximum, local maximum if we're dealing with something continuous, right? Okay, so absolute minimum. This is just the largest, like overall for the entire space that our function is, right? So this will be the smallest, not smaller, but smallest value our function takes. And I guess we could write on a closed interval. We'll see why this matters. Again, it's getting a little pedantic, but we could imagine if we change this previous example and instead of having a closed thing here, oops, that's not my white pen. Yo. And we had an open point here. Now we never really reach that largest value, and so it is not a absolute maximum. In fact, we don't have an absolute maximum because once you tell me you've met it, I can get just a slight bit closer. It's sort of like infinity, right? If we're on an open interval, we break stuff. So this is why we need that closed interval. So relative is just smaller or larger than stuff around it. Absolute is the smallest or the largest value our function takes on a closed interval. I'm going to be lazy and not write here. So we've got an example here. It's on a closed interval. And so we can look at all these beautiful points. We can see, okay, we've got some like dips, some like kind of lowest points in their neighborhoods. These are relative minima or local. Minima is the plural, but I've already written minimum. It's too late. Can't change it. We've got a local maxima. Right? It is larger than these values to either side of it. So it's a local max. And then we think globally. What is the smallest thing and the largest thing on this overall function? And we've got, whoop, this point looks to be our absolute or global maximum. And our minimum value, whoa, it's also here. Now, that leads you probably questioning a couple things. One, WTF is this? And to answer that, it's an endpoint. It's nothing special. Doesn't matter that it's larger than the stuff to the right of it. It's nothing. It gets no special names. It is wah, 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 just a sad little endpoint. Cool. Also, how do we write these? Because this is something students struggle with a lot. So we have two different questions we could be asked, which is where does that absolute maximum occur? And the other is what is the absolute maximum, right? So if we were to write that out in words, you might say something like the absolute maximum of 5 occurs, ooh, that's not an O, occurs at x is equal to 11. So just be very careful. When or where is about the x value, right? When does this occur? Where does it occur? That's about the input. What is it? That's about the output. So pay close attention to your questions, answer them appropriately, because a lot of times I get a lot of almost on the upcoming quiz based on just the writing that happens here in terms of defining where and when these things happen.